I'm pleased to introduce a double act from Mott MacDonald. So it's in the form of Gwilym O'Donovan and Sam Anstis. Gwilym's a geographer and a GIS consultant with a specialised focus around surveys and data collection, and a bit of a penchant for Esri's mobile data collection tools. Sam, like a couple of the speakers today, actually, is a fellow of Swansea University alumni member, and he's a very much focused on data automation. He can turn his hand to a little Python as well if required. They're both going to tell us now about how FME fits into the workflow of moving data between the office and the field. So thank you both.
Yeah, cheers, David. So yeah, hi everyone. So I'm here today with colleague Sam. So both of us are GIS consultants working for Mott MacDonald. And today we're going to be talking about how our GIS team is streamlining automating processes in our everyday tasks for the use of FME. So throughout our working week, specifically in the ecology sector, it's led us to do more for less and has made our data integration between the office and field more efficient. So let me introduce Mott MacDonald. We're a global engineering, management and development consultancy with over 16,000 employees with offices in 150 countries. We work in partnership with a number of environmental, rail, nuclear and utility sectors. Our core aim is to make a sustainable difference to the world we live in that translates into a focus on understanding our clients and their customers to deliver outcomes that add value. Our clients are always looking for innovative solutions and interested in new digital technologies to help resolve worldwide problems. For the use of FME, we've enabled these organizations and our clients to make data-driven decisions by increasing insight through automations. So in terms of the environmental impacts, for example, on a large-scale construction project, before we can get the go-ahead, a habitat classification of the area needs to be completed. This is called the Phase 1 Habitat Classification. JNCC, or Joint Nature Conservation Committee, have published a set of guidelines for this process, where each output is standardised across the UK and where each habitat type is defined by way of a brief description and is allocated a specific name and unique mapping colour. So the problem with our previous non-digital workflow is that employees would go to site, they'd write on paper, which would then be digitised later on in the office by a technician. As you can see, we've got some images of these site notes, and it's quite difficult to interpret, and I'm sure all of us will interpret it differently. So this would link back to an increase in project costs, increase in time, and the potential inaccuracy with data quality, which could lead to misinterpretation. And ultimately, decisions would be made on this. So previously, this way of working was delaying the project. So the solution, and through the use of FME as a key enabler, is allowed us to work in a more innovative and efficient way by pre-classifying these Phase 1 habitats geospatially for the use of FME Workbench. Working in partnership with the Ordnance Survey and the use of their range of products, they already provide a very accurate picture of the UK, so we decided to take advantage of these data sets. The Ordnance Survey Master Map topography layer gives you access to the most detailed, current and comprehensive geospatial data set of Great Britain. Inside this data set, there are certain attributes or rows of data which provide land themes and area descriptions. With a relatively simple FME Workbench, as you can see in the top right, it's allowed us to pre-classify these habitats. So the images shown are the examples of the output from the FME Workbench. As you can see in the bottom left image, the Phase 1 habitats are pre-classified with their respective code, name and mapping colour, as well as converting it from the origin GML dataset into a more usable format that we like to use. So that'll be either Esri geodatabase or ORCAD DWG file. So that's with a click of one button. Dataset is very detailed, accurate, and can even be taken out on site and amended if an area of habitat has recently changed. So effectively leading to improved efficiencies across the board. So these are some of our future developments which we plan to do. So number one would be introducing a new custom transformer, so converting this data set into the new UK habitat classification system. Another development would be number two, to automate the process even more. So that'll be by bolting on an ArcGIS online writer for use with a tablet on site. And lastly, number three, would be to looking to move to FME server with automating the entire process as soon as an order confirmation email arrives in our inbox from the Ordnance Survey. And now I'm going to hand over to Sam, who will talk about the work we're currently undertaking on biodiversity.
Thanks very much, Gwilym. There we go, fantastic. Okay, so do I have control? Yep, there we go. So in 2019, the government produced the Environment Bill Policy Statement, which, when the legislation comes into effect, will legally require developers to ensure habitats for wildlife are enhanced with a 10% increase in habitat for wildlife compared to the pre-development baseline. This means that councils across England will have the duty to ensure that any plans or projects provide biodiversity net gains. DEFRA have produced a metric and have published guidance on how calculating biodiversity loss and gains as part of a development, which is based on habitat measures and valuations. This includes looking at the connectivity of habitats within a site, the condition of those habitats, their distinctiveness, whether the site has been deemed locally significant for nature, as well as the various other risk-based components such as the difficulty of creating or restoring those habitats and any temporal risks as well. The tools that DEFRA provide require a two-step process. The first step requires the user to supply GIS data to calculate connectivity between habitats within the site. However, the bulk of the assessment is done within an Excel spreadsheet. Users are required to input the total area of each habitat type present within the site, both pre and post development, once mitigation has been completed. And this process is both time consuming and error prone. As you can imagine, a misplaced decimal point could massively skew the end result. And for larger sites with a large number of habitat types, this could become hard to track down. To reduce the time and the cost it takes to perform these assessments, we have looked to FME for a more automated approach. Following the logic of the DEFRA system, we've been able to recreate the assessment, as well as add in other benefits. The Workbench's ability to pull in and work with multiple formats, assessing and integrating various data sets allows for a faster, more foolproof approach. Custom transformers assess the spatial data, providing scores for distinctiveness and strategic significance, as well as the various risk-based components of the assessment. Spatial attributes are retained by scoring the individual features, whether it's an arable field or a grassy meadow. This process provides a pre-development baseline, and using landscape plans, this allows us to assess the site post-development too. These two data sets are then divided to assess habitat within the working area, as well as any off-site mitigation, and is scored to provide the total biodiversity unit, allowing for us to identify any potential net change in biodiversity. The use of FME has also allowed us to provide other benefits. For example, as Gwilym has already mentioned, FME allows for the extraction of habitat maps from OS master map data. Integrating this process and in combination with any existing phase 1 data we hold for the site, we can produce a preliminary baseline, providing indications of biodiversity cost for development before any further habitat surveys have been completed. Other elements of the Workbench allows us to perform a topological check. This is especially useful as we intend the tool to be used by those less knowledgeable about GIS and who may be unaware of such errors. If the user chooses, the supplied data will be assessed and will be provided with a warning if any topological errors are identified, and a report will be generated with those errors summarized. So in summary, FME has allowed us to make use of custom transformers to extract more use from complex data sets. It's allowed us to streamline the collection and utilization of data between the office and the field. Integrate multiple data sets of varying formats, enabling us to extract as much potential from our data as possible. To assess the impact on biodiversity as a result of our work, allowing us to be better informed. And through increased automation, enables us to achieve our economics and sustainable development goals. Thank you very much, and I will hand it back to David.
Thank you both. That's superb. So we've got a little bit of chatter. So actually, one of our speakers later on, Helena Sykes from Natural Resources Wales, has actually suggested you guys get in touch with her. I will. I'll connect you both after the event because she has said that it'd be good to talk about the Living Wales project. There's a mobile app, EarthTrack, which records LCCS land cover classes, and it also maps across to phase 1 classes. So she thinks that might be relevant to some of what you've been covering. So I'll put you in touch after the session.
Fantastic, thank you very much.
There was also a comment about what formats you chose to use out in the field and why.
So in the field, what we do, we actually input this into ArcGIS Map or ArcPro. So we upload a geodatabase to a hosted feature layer on ArcGIS Online, and then we use ArcGIS Collector to edit all the vertices and if anything's needed. So basically, it's a ground truthing once you're on site with the data.
Okay. We've also had we tend to see this a little bit for a couple of the sessions, and it's worth saying that a few people are asking for workspaces that they've seen. Now, obviously, a lot of the organisations presenting their work are, they've built these processes as part of their commercial process. It's going to be down to whether they, as an organisation, are prepared to open it out. I suspect that in some cases the answer will be a polite no on most parts, but I mean, we'll put people in touch where there is a specific workspace that they've requested, and then you can answer that for the direct to the individuals. There was one other in here about the custom transformers that you showed, asking how you manage custom transformers within the business. So how you, I guess that's alluding to sharing
right.
between workspaces and that kind of thing.
So yeah, I think what we normally do, we're using SharePoint as a basis. So in Mott MacDonald specifically, we've got an OS partnership SharePoint site, and all those workspaces, well, they're designed to use FME Quick Translator, because people outside of the GIS practice will use those. So you don't actually necessarily see the custom transformers.
Right.
It's only GIS technicians which actually create those custom transformers.
Okay. All right. Super. Well, that's really great. Thank you both for joining us, and thank you for your session.
No worries.
Yeah,
thanks a lot.